Hello, everybody. This is Sparing Partners, and I am Monica Paolini, your podcast host. And today I have a very special guest. It's Magnus Olden, the CTO at Domos. And he is special because he's going to talk to us about somewhat of a different perspective, which is the perspective of the application developers when it comes to APIs. So a little bit of background on the topic here. I'm working on a report on APIs, and as I'm doing the research for the report, I'm finding out very interesting things. And clearly there is a lot of interest on APIs, but and I would say one area that we don't focus, I think, enough is the view from the application developers. So it's all good to have APIs that are standardized, that all operators have, and all of this, and they're going to be useful for application developers. But let's just look at APIs from an application developer perspective. What is that they're looking for? And so we all hope that they're willing to pay for it, but under which conditions are they willing to pay? How much? And I'm not talking about the dollar amount here, but how do we think about it? How can you make the APIs attractive to them? Because it can be a good thing, but will they appreciate it? So, Magnus, welcome to the podcast.
Thanks, Lon, and thanks for having me on.
So let's start, and maybe you can introduce yourself and tell us why you have such perspective on the APIs.
Well, okay, so I work in Domos, but I started out basically developing. When I came, my background is in IT and data science. Kind of coming out of school, I did do programming. I was an app developer. I eventually got into telecom and kind of have that perspective as well. But through Domos, some of the things we're trying to do is to expose APIs to developers, and we spent a couple of 2-3 years ago. We started talking to developers again. I started talking to them again and trying to figure out what they want from APIs and getting their perspectives. And we learned some things that is kind of different from what most in the telco industry are talking about when they're talking about network APIs. So I feel like there's a kind of a mismatch between what the telcos want to give out and what application developers actually want and need.
Yeah, absolutely. Now, actually, I forgot already to say this, but one of the inspiration for writing the report is a meeting, actually two meetings that you hosted recently on APIs. And I thought that was very, very, not only well done, but I got a lot of information on it, and I'm going to put it in the notes for the podcast. I'm going to put a link to it. But and what you did that was great is actually to promote this kind of debate and talk about this sort of mismatch. So what is it?
Well, I'll tell you a bit about the event first. So we did two-day
Okay.
event where we invited. The first, it was kind of for application developers, and we had some application developers that came there as well and talked about, hey, what do we need? What do we want? Then we had a second day, which was more for the telcos and talking about what are the possibilities? Why should you implement this? How should you do it, right? So that's the event, and kind of you learn what from these things. But we knew who to invite because we've been trying to work with them for a long time. So kind of this mismatch, or there is a bit of a mismatch in expectations, right? There's a bit of this idea from the telco side, just hey, if you just expose APIs, developers will come like they came and used the internet when it first came out, right? Developers will come. And on the other side, you talk to developers who are very much looking at fixing lots and lots of problems and just want solutions for the problems they have, right? So if you start thinking about just for making the simplest app, all the kinds of problems you have, right? One of them is maybe, how do you get disk space? Like how much disk space do you have? And then there's the network, and then there is memory, and then there is security, and then there is, yeah, all kinds of stuff, right? So lots of problems. And what I found that the developers we talked to, and kind of rings true from when I was a developer as well, is like, hey, I have a list of specific problems and I just want to solve them. And then trying to figure out like, hey, is there a match between the problems developers want to solve and what the telcos are promising to solve for them with network APIs? So yes, there is certainly an overlap, but there are certainly missing pieces as well.
So what are the missing pieces?
Well, there's quite a few, or there is a few, right? So very important one is coverage. Like, okay, you have network APIs. Do I always have them? Is this just for telco X, or is it for telco Y, C, right? Kind of a lot of telcos are talking, hey, it's just for 5G, 5G SA, right? And then the app developer is like, what is 5G SA? I have no idea what that is, right? I don't want to deal with that. Like, just give it to me. And if it's there, I might use it, but I don't have a concept of 5G SA. So that's very much one problem. Like, is there coverage? Who does it work for? Does it work for every operator? Does it work in every country? Kind of like many apps are multinational. Of course, some are not, but a lot are. There's use cases on both sides of that aisle, but both kind of we need like at least one country's coverage before most apps make sense, right?
Yeah.
So this how many operators, which networks are they on? And there's like one thing that I'm very interested in is the home broadband as well. Like, is that covered? We know that 80-90% of all data goes on Wi-Fi. Most of the use cases people are talking about when it comes to network APIs is only covering mobile networks. So is that part of the picture? And when you think about it from an app developer's perspective, like you have this list of problems you want to solve, and you often have a budget for solving them, but you just want to find the easiest way to fix each problem. And there are few set of problems that maybe only network APIs can solve. There are certainly like a lot of problems where you can get 80% solutions from in other ways. So kind of these are kind of the major problems. And then there's more technical problems in discovery and like how you figure this out, and security and privacy and these kind of things. But I think you can make network APIs quite popular if it had global coverage instantly and all networks and whatnot.
Yes, and absolutely. And this is an issue. So coverage. So whatever an operator does individually, it's just not going to address the need of the app developers. You need to have multiple operators moving in the same direction. And also there is also the Wi-Fi inclusion, because as I say, most of the traffic goes through Wi-Fi, above 80% probably. So if I'm an app developer, whatever I'm doing, I need to have the API that covers all the networks in whatever areas possibly, and Wi-Fi as well. But now the GSMA Camera APIs are mostly focused, although they're not tied to the cellular networks. As I say, as an app developer, I don't care whether it's 5G, 4G, standalone, or whatever. I just need it to work for everything.
Yeah.
So how do we go past that?
Yeah, no, we have to get started somewhere, right? So it's not that bad. There are certainly many very specific use cases that you can solve before we have this full coverage, right? Starting from maybe campus networks for specific networks in stadiums and for concerts and whatnot. Maybe some networks for very specific, I don't know, drone use cases, these kind of things. Like I think that will get it going, and that will be the beginning, right? You don't need this kind of hyper consumer use cases with 1 billion users to get going, but I think that's when it's get really, really interesting. But I think these specific use cases will get it started and kind of help fund the rollout and make sure that, you know, people see that you can actually make some money here. There is competitive advantages here. So that's where we have to start. There's a second thing, and I want to promote this to all the operators, and that is doing what in the software world is called dog fooding, which is basically eat your own dog food. So what Microsoft does and how these Google does is when they launch a new tool or a set of APIs, they make sure their internal organizations are using it. So that way you get usage, you get growth, you get support because they're big companies, right? And I've seen some operators are starting to do this as well, where they are starting to expose APIs, but they're also using them themselves, right? So if they're exposing APIs for upgrading your data packet, they're using that same API in internal processes as well. And kind of using these combined, I think, is the key to kind of get the ball rolling, because it is a chicken and egg situation.
Absolutely. And I think that that's also this way they can get more comfort about the exposing part so that they understand better what is that they expose and what are the implications of that. So not only whether the API works, but what does it do to their network, and we might get to that later. But okay, so but the other thing is that, you know, an API is sort of a very broad spectrum kind of thing, because I am an operator, I have an API, I want to reach out to everybody with that. But then from an application developer point of view, I only have, let's say, one application, or, you know, a very specific focus. So I'm gonna need a subset. I might need to have it, you know, set some parameters. So you kind of like, you branch out with an API, reach everybody, but then you want to kind of narrow it down so that the API is useful to a specific app developer, right? So how do we get to that part?
Yeah, and I think developers are kind of used to working with these kind of problems or this way of using it. If you look at, say, if you go into AWS documentation, Azure, or these kind of big things, tons of APIs and whatnot, it's very much tied down to specific use cases always, right? And they're very good at, you know, providing documentations and guides as, hey, you have this problem, use this API to solve it. And then they have a more general one, which typically goes into more like things that goes across APIs, which is more like, hey, I need to have some authentication because you can't just let anyone use it and whatnot. So I think there is tons and tons of complexity in the telco world, technology kind of thing. You want to hide that complexity, and you want to highlight specific use cases, right? You want to make an abstraction for use case. Like one of my examples is the light use is okay, there's quality on demand, right? You heard of that, Kamara. There are network slices. There are different implementations of quality on demand. The kind of all of this from one of the use cases for all of these is to make the network better for a specific app or device. Like the app developer will not care whether that is on the network slice or quality on demand, whether that is done on QCI or whatever other technology, right? They just want to make the network better. So you need to make it a use case that's like, hey, I want to make the network better for my app or a specific app. And all the complexities of networks below, you need to hide for them, right? They don't have to deal with them. So what this kind of API provider typically does is they make it layered, so you can go into the detail if you want to, but absolutely most will just do the simplest thing, right? So this is kind of the challenge, I think, for a lot of people in the telco world, is to think or say, hey, we expose network APIs, but they're very often very complex and very often uses about 15 different three-letter acronym. So no one understands them outside the telco business. And everyone is scratching their head, right, if you're coming from the outside. So this is gonna, I think, you need to turn around and say, hey, like, this API solves that problem. Here's how you do it, done, right? That's it. It can't be more complex than that.
Yeah, now you mentioned network slicing, and that's all related with the, quality of experience, quality of demand, and things like that. And right now, maybe, okay, we're still kind of far away from actually getting it off the ground in major ways, but let's say it's wildly successful. Okay. You have a situation where you're going to have a competition. So you have your API exposed in all your capabilities. But where is that app developers are going to be more willing to pay is where there is less capacity. Otherwise, you don't need to have network slicing. So we are in a downtown area, whatever, high density area, everybody's willing to pay for it because this is wildly successful, but the operator cannot just sell it to everybody. And so you need to know how likely I am that what I'm paying for is actually going to deliver, or that I'm going to be able to have that kind of a thing, that kind of quality of experience when I need it. Mm. So there is a sense that if it's really successful, we still might have a problem because the network resources are what they are. So how should we think about that from the application developer point of view?
No, like, this is back to what one of the things Domos is doing, right? So that's one of the things we try to help telcos with, is to simplify this equation by using proper math to calculate kind of probabilities of meeting different SLAs and network requirements, and kind of try to calculate what we call a proof of enhancement, or what is the likely improvement of using different techniques, and also what are the side effects. But I think in the case where this is widely successful, right, then there certainly is going to need a controller that is much smarter than what we see today. And we also need to expose more network data and capabilities so that it is possible to have these kind of, if you read net neutrality regulations, for example, you can prioritize and differentiate when it's reasonable, when there's transparency and whatnot. There is openings for these things. So if it's successful, I think it will be a very complex cost-benefit analysis that kind of gets into a sort of bidding round based on, hey, what is the likely increases, and because there is need for transparency and reasonability, it will just sort itself out. In that most applications maybe don't need to have super low latency, for example, but some do, right? So if we're looking at these different network requirements, so network requirements for a YouTube stream versus a video conference, right? Video conference requires less latency. Yeah, can you actually prioritize or differentiate for the video conference and improve the likelihood of good quality for the video conference without reducing it for the video stream? If yes, then this makes sense, right? So the cost-benefit analysis makes sense. There are other scenarios when it doesn't make sense. And I think, there will be a lot of complexity of solving this with net neutrality compliance. I still think it's possible, but it will require quite a bit of math, and I think actually just exposing more data from the networks. Of course, the apps themselves do not want to deal with this at all. right? So you need to fix it before you expose it to the app, for
Yeah,
sure,
absolutely.
right?
Yeah,
Because
I
this
mean,
is 5 layers down in the telco world that they do not want to be.
yeah. So I guess that, net neutrality is, so sometimes, people think about net neutrality as protecting the app developers, but is it?
Yeah. No, that's a good question. Like, we're using network resources inefficiently. We know that, right? Um, and there is certainly room for improvement. It is protecting them in some sense from telcos just degrading network quality for competitive apps. I don't think that has actually ever happened, or at least I've never heard of it. But in theory, it's protecting from that. But it's also complicating these things, right? There is no doubt that some apps are more latency sensitive than others, right? Does it make, and you can kind of prioritize one of them before the other, or quite strong levers before it makes any difference to the non-latency sensitive app. So it just means that, hey, instead we have to overbuild so we make sure there's never any latency, right? So yeah, does it protect? Like, yeah, yes and no, but it's certainly complicating. That being said, there has been some development in net neutrality, or making it clear from some regulators that there are possibilities for differentiating for classes of app and whatnot. But it is still protected by quite complicated law talk. So it's an abstraction I would like to skip, but unfortunately, there's no one has done that yet.
Yes, absolutely. I want to ask you a final question, which is again to sort of the cost benefit analysis related. So APIs, hopefully, once correctly implemented, are going to make the life of software developers easier, and therefore they're willing to pay for it. That's the logic. However, there is a substitute to it for most of the APIs. And maybe there are some specific things where you do need an API and otherwise you cannot do it. I mean, an API from an operator. But let's say fraud. I mean, people are dealing with fraud today in some ways. Now, APIs will make it easier and better, but you do not really, really need an API to protect yourself from fraud. So if I'm a bank, I'm going to be willing to pay for it, but only to some extent, and only to the extent that that's actually really helping me. So coverage is one issue, but willingness to pay is another one. And for most APIs, as far as I understand, there is a substitute that doesn't require an API from an operator. So how do we think about it? How important are they in actually solving real problems that cannot be done otherwise? Or that you don't have some sort of like location, where people are, even if you don't have access to the network uh capabilities. It's just not as precise, but
Yeah, no, actually, I think it's more precise often, but
okay, right.
there's a different there's a different thing. Now, so I think let's do the fraud case, or actually both the cases you talked about. So, which is, yeah, so let's do the location one. And there is not, maybe it's not simpler, but less likely to be spoofed, right? So the way we use location today is like you look up a GPS, you get this, you use an API for that on the phone, or I don't know if you in the browser, you see like, hey, would you allow this app to get your location and whatnot? So there are very simple way of getting the location right now. The question is, and I think this is in the bank case, like very security concerned cases, this is not good enough because it's very easy to spoof a GPS, right? You can buy, I think a $20 device on the internet, maybe not legally, but you certainly can buy it for a very low price that will spoof your phone's GPS, so it will think it is in a different location. right? This is a very easy, simple thing to do. For these like very specific use cases where you really need to know, like someone is who they are, telling you they are at the location they are telling you. There is not really a good substitute for what a telco could provide, because a telco say, hey, VR can triangulate. Like it doesn't even matter if it's how precise it is, but in general, it's in this location, right? We know that Monica is at our house. She is not a deep fake I'm talking to right now, right? This signal is coming from her house. Oh, I think it's not a deep fake.
You never know.
They're getting pretty good. So the GPS case or the location thing is very much, hey, here's a more secure way. And again, like for most apps, they will not start using network APIs to get location, because there are very simple ways of getting location. And there are APIs for that millions of people have been using, and it's free, right? But for very specific high concern use cases, that can make total sense, right? So that's one example. So you can start out with this specific use case, and I think that's the way to get the ball rolling. You start out with these specific use cases, and then what we hope will happen is that, hey, this is just a better way of getting GPS or getting location, so we will just start using it. You start using it in one app, you start using it in another app, right? And I think, yeah, with the advent of, or what we're looking at with AI now, like, is this person a deep fake, will get a much more relevant question, right? Are these people, how do we verify that people are who they say they are? I think, like I discussed with some enterprises who really want to like have strict rules that you can only work from the office or your home, but they have no way of verifying that you're at your home, right? So these kind of things, like I think there will be lots of use cases around that. Around with different like SIM swap, like fraud use cases, I think is similar. Network quality is of course one thing where there is, the only way you can do that is by working with the network, right? There is no other way. So I think that will be use cases as well. But yeah, in general, I think just let's start making these very specific use cases clear, and let's get people to start using them, and then I think it will evolve from there.
Absolutely. Magnus, unfortunately, our time is up, but thank you so much for sharing your thoughts with us today.
Thank you for having me. It was great.
And thank you all for listening. And if you like the podcast, do subscribe to it on the platform you choose, and send us any feedback or suggestions at podcast@sensafidi.com.